Hello, this is Doug, WE6Z, and I'm going to talk about the Kon-tiki transmitter that I built. The Kon-tiki expedition was a 1947 journey by raft across the Pacific Ocean from South America to the Polynesian Islands, led by Norwegian explorer and writer Thor Heyerdahl. And he brought along several radios with him. Specifically, the National NC-173 receiver and speaker, and several transmitters that were built by an engineer from National Radio Company. Here are a few pictures from the expedition. Here are the radio men disassembling a B battery to build an A battery. The transmitters for the expedition were built based upon an article written by Calvin Hadlock, W1CTW, in July 1941 QST. In fact, this is the first page of that article. And my goal was to build a transmitter based upon those plans using as authentic and period correct parts as possible. So here are some of the parts that I used. Here are some vintage World War II parts that I scavenged from an old chassis. Here is that radio chassis, and I just got in there and cut out all the components that I needed. Fortunately, most of the components had the values in the ranges that I would need for this project. I decided to go with a bud box and an aluminum chassis. So this is the aluminum chassis and this is the bud box that I was putting it in. And I also needed a faceplate. I found this piece of metal that just happened to be almost the exact same finish, and I ended up cutting it to fit. The Kon-tiki transmitter used a 2E30 tube, but the original article could use a 6V6 or equivalent battery tube. So I decided to go with the 6V6 and later the 6L6 for the RF amplifier. Their call sign was Lima India 2 Bravo. Here's a picture of the National NC-173. And one of the radio men in his operating shack on the raft. I decided to look around for some inspiration on how to configure the controls and meter, and this is one of the radios I liked the design of, so I figured I would make it even and like this. So gathering some of those components, this is the article and the schematic and all the values needed. It's actually very relatively simple. I combined some resistors together to get the appropriate value and wattage. These mica domino capacitors, even being over 70 years old, still were holding within a couple picofarads of their original marked values. I found that pretty cool. Here I was attempting the layout, trying to figure out component-wise where everything was going to go. And I have both the Hammerlin coil and that black coil form to wind the coil on. This is actually the parts bag of parts that I put together for the transmitter. another layout test. Here's some plates that I was thinking about using, nameplates. Doing some measurements and trying to figure out where exactly things would go. I also wanted to add some numbers to the knob position so that you could say tune it to 4, 10, or whatever it was. Still designing and laying out where the components are going to be. This is, I decided to put the crystal sockets on the left, the tube sockets on the left, crystal socket in the middle, and the capacitors in the right center. And for example, I was using some of these metal tubes just as a placeholder here to see how it all lays out visually. I had to use epoxy to put the crystal socket in there because I drilled the hole too big and didn't want to, plate over and all that other stuff. So I just epoxied it in, added some terminal strips, and added a ceramic octal socket on the back for power supply connection. Here's some of the initial cloth wiring here for the filaments. And testing the tubes to make sure the filaments were wired correctly. These are two 6v6s. I cheated and used a modern 350 volt power supply, but it uses a 5Y3 rectifier. So it's still authentic, not period correct though. And more wiring, I'm marking off which components I've added. Doing testing at multiple different stages. Checking to see if the oscillator is running. Voltage and measurements. Here is the oscillator running with a 7 megahertz crystal at 7.017. And all point-to-point wiring using those vintage components. And had to calculate the Pi network because I ended up going with a Pi network output instead of the original link coupled coil because it was easier to build. So calculating out things, building the coil, and selecting the capacitor value for the plate and load. And there's my coil. I added also a neon lamp indicator to indicate maximum voltage to help visual tuning aid. I was working on designing the Pi network output and simulating the plate load so that I could make sure that the Pi network was working. I found a different crystal that ended up working better in the circuit. Here's the neon lamp indicating the peak of the tune on this capacitor. Testing some tubes, testing the 6V6s and 6L6s. Installing the controls. Fabricating the bud box so that everything would fit. Adding a B+ switch and a key jack to the front. And I found some new old stock 6L6 and 6V6 metal tubes and used that. And mounted the sub-chassis into the box and wired up the controls and the meter. And I decided to make up some labels as if I didn't have any tools from the 1940s. So I used some metal punches and some sheet metal to make some nameplates and glue them on to the front of the transmitter. And there you have it. Using the transmitter on the air, I was able to receive it about 50 miles away. Puts out 4 to 5 watts on CW and worked fairly well. Thanks for watching.